Hi Nathan, this is Anita, and I am back to conclude the how to build a PC instructional video, and I'm going to begin talking about some of the components on the motherboard and give an in-depth knowledge base of these components as well as how they work with the PC. Okay, so one of the first things that I want to talk about today is BIOS and the difference between ROM BIOS and the CMOS BIOS. So let's get started. Okay, so I'm going to start my demonstration off talking about uh, BIOS and CMOS. And as you can see that I am using a Dell motherboard. So we're going to start with the ROM BIOS, which stands for read-only memory, and it is a chip on the motherboard. And this chip contains a pre-installed program that helps the computer processor or interact with the devices or the components in the computer. Now, these devices consist of keyboard, memory, video, and other components. And so, without the BIOS, the processor would not know how to interact or interface with the computer components, and the computer would not be able to function or start itself. So this program, what we know is POST or power on self test, does a hardware check initially when the computer is started up to make sure that all the hardware is working properly. Now, if there is a problem with the post testing when as it goes through, it gives off an error or some beep codes to let the technician know that there is a hardware issue. And but these beep codes can be different depending upon the manufacturer of the BIOS. So you need to consult the manufacturer's website for that motherboard to check the beep codes to make sure that you get the proper one for those devices connected to that motherboard. Okay, so let's talk about the CMOS battery, which is known as complementary metal oxide semiconductor, and it is a chip on the motherboard as well, but as known to technicians, it is called the RAM chip or random access memory. And this chip contains information about the computer components and their settings in the computer. But sometimes what happens with the CMOS battery, just like any other battery, it loses power or loses its juice. And so what needs to happen, battery needs to be replaced because every time you go in and make the changes and the computer is powered off, those changes are lost. So that is a sign that that battery needs to be changed out. Okay, like I was saying earlier, the BIOS chip and the CMOS chip, they both work together collectively. And what the run chip does is it reads the CMOS chip information when the computer is initially started up or doing the booting process. And so when the post initially is going through its power on self test to check the devices, there's an option where the technician can hit some function keys on the keyboard to enter into the CMOS settings. And so once you hit those function keys, you enter into the CMOS settings and not the BIOS settings. Now the BIOS chip cannot be updated, like we go in and we update or go in and make changes in the CMOS. That update is called flashing the BIOS or a BIOS update. And the only way that this can be made changes to is it has to come from that motherboard's manufacturer or the computer manufacturer. So the CMOS chip lets you make changes like the date and the time and the settings of how devices are loaded into startup. So generally, the first device that we want to load is the hard drive where the operating system has been installed. So, but we can make those changes, and the CMOS setup it need to be changed. So that is pretty much the information, brief information on both the ROM BIOS as well as the RAM BIOS located on the motherboard. Okay, so I'm back again, and the next topic I'm going to talk about is hyperthreading and hypertransport. One goes with Intel, and the other one goes with AMD. Okay, hi, I'm back again, and today we're going to talk about CPU, which stands for Central Processing Unit, and the different kinds of processing units. We have the 34-bit processor, and we have a 64-bit processor, and the different types that come along with that, like the quad core processors. Okay, so today we're going to be talking about the central processing unit, known as the CPU, brain to others, and or the processor. So most of the calculations take place in the CPU, and it is the most important component on the motherboard. So some CPUs come in different form factors, and those particular form factors is either a slot or socket on the motherboard. And the common manufacturer of processors is AMD and Intel. So I have a Intel motherboard, as you can see here today, on a Dell Intel motherboard, and it has a what we know to be a socket or ZIF, zero insertion force, and that is where the CPU it fits down inside of the socket on the motherboard, and this level locks it in place because of the force that it needs to be installed on the motherboard. Okay, so let's continue to talk about the CPU and the difference between the 32-bit and the 64-bit architecture of the CPU. Now, the 32-bit processors were the primary processors used in all computers. Both Intel and AMD use 32-bit processors. The operating systems that were installed, as well as the software or applications that were installed on a computer, were 32-bit based as well. And so those examples of operating systems would be Windows 95, Windows 98, and XP. They were all 32-bit operating systems, and they were the common software that was installed along with the 32-bit processor. It is important for us to know that a 64-bit processor can have a 64-bit and a 32-bit operating system installed. But with a 32-bit operating system, the 64-bit processor would not run at its full capacity. Okay, still talking about the 32-bit processor and the 64-bit processor. And the big difference between them is the calculations in which they do per second, and this affects the speed in which they complete their task. Now, 64-bit processor comes in a dual core, quad core, 6-core, or a 8-core processor. Now, multiple cores allow for the increased number of calculations and the performance in which the processor performs. So, given the cores that are on the processor, the better the performance. I also want to add about the 32-bit and 64-bit, the amount of RAM. Now, 32-bit can access up to 4 gigs, and a 64-bit can access up to 6 gigs or more. So the 32-bit lesser RAM, 64-bit more RAM. Okay, so what hyperthreading does is that it executes multiple threads simultaneously through the CPU. And to the operating system with a single CPU, it performs as though there are two CPUs when these performances are taking place. Okay, so let's talk about hypertransport. So hypertransport is a technology used on AMD processors that is to enhance the CPU performance. And with that performance, it is included high speed and low latency connection between the CPU and the North Bridge on the motherboard. Okay, so now I'm going to talk about cooling fans, heat sinks, and thermal paste. Okay, so we're talking about cooling fans, and in this particular form factor or system, there's three major fans, and so these fans work to either pull heat out of the system or off a particular device, and or to put cool air into the system. Now, the ones that are installed on this particular system is a fan, which you see sitting here on top of a heat sink that sits on top of the processor. We have a case fan, and we have a fan that is installed on the power supply. Okay, so the first cooling fan I'm going to talk about is the fan that sits on top of the heatsink, which sits on top of the processor. So the heatsink has a thermal paste or thermal compound that is on top of the processor, and so that is glued to the heatsink. The processor and the heatsink are glued together, and this fan helps pull the heat from the heatsink to keep the processor cool. Now, the power supply also has a fan connected to it, and so it keeps the power supply cool and helps as well as a cooling mechanism to keep the power supply from overheating. Then we have our case fan. Our case fan or system fan, which is located on the back side of the computer or on the side of a laptop, and both of these are, it draws air or hot air out of the system so that the system can stay cool and won't overheat. They all pretty much work in conjunction together to keep the system from overheating. Okay, so let's talk about a little bit about virtualization. Now, virtualization is usually referred to as running multiple operating systems on a single machine. Now, while most computers have only one operating system, virtualization software allows a computer to run several operating systems at the same time. So let me give a brief description of what virtualization does. The virtualization software acts as a layer between the primary operating system and the virtual operating system. And this allows the virtual machine to access the hardware of RAM, CPU, and the video card. We also must take into mind about the RAM and making sure that there is enough RAM installed in the host machine to run both the primary operating system as well as the virtual operating system. Now, in the virtual environment, we can do the same things that we do in a primary environment, like browsing the internet. We can test out of software and updates to make sure that they won't be harmful to the primary environment. And it also, you can run old applications in the virtual environment that won't run in the primary environment. Okay, talking about the difference between USB 2.0 and 3.0. Now, it is a common interface that is used for a wide variety of external devices today, such as your printers, scanners, cell phones, and other external devices. And so, when this USB device is connected to a computer that supports plug and play, the device is automatically detected and the start of the driver's installation begins. So the difference between 2.0 and 3.0 is the speed and the backwards compatibility that it has. Now for 2.0, the 2.0 speed goes up to 480 megabytes, where 3.0 goes up to 4.8 gigabytes. And in 2.0 is backwards compatible with 1.1, where the backwards compatibility for 3.0 is 2.0 and 1.1. So when we use devices that are 2.0 but use the 3.0 port, it only can go up to the speed of 2.0 as the same for 1.1. So that is a difference, basic difference between those two, 2.0 and 3.0. And the colors for 2.0 is a basic black, maybe sometimes gray, where for 3.0 the port will be blue. Okay, so next I'm going to talk about the different network types such as LAN, MAN, WAN, and PAN. Okay, so in this visual, we're going to be talking about the different types of networks. And the network that you are seeing here is a LAN. And LAN stands for Local Area Network. And a LAN is generally found in small areas such as office buildings, maybe even a classroom such as this, or even the residential homes, which is called a small office, home office. Now, what you're looking at here is a classroom, which is a Cisco networking classroom. And what LANs allow users to do is share information across the network, such as printers, files, and other components. And again, I said this is a Cisco networking classroom, and in this classroom, some of the computers are wired, and some of the other computers are wireless. And back here, I'm going to go and show you some of the equipment that is being used in this particular classroom. Here, you have your switches, and down here you have the Cisco routers. And in this classroom, the students learn how to configure switches and routers with commands. Still talking about a LAN. So a LAN may be connected to other LANs. It could be also connected to the internet or to the WAN. The smallest LAN could have at least two computers, while other LANs have hundreds of computers connected to it. Now, in a LAN environment, the components that you're going to find will be hubs, switches, routers, Ethernet cables, and other components that bring it to becoming a LAN. So in order to connect to a WAN, you must have an ISP provider to be able to connect to the internet. And your ISP providers examples would be Verizon, Comcast, AT&T, and maybe Time Warner, or those providers that would give you access to the internet through the WAN. Still using this visual, but I'm going to talk about another network, which is a MAN. So MAN stands for Metropolitan Area Network, and it is a network that spans across a campus or an entire city. So a MAN is a network that consists of various buildings that interconnect together through wireless and fiber optic backbone. And with the communication links and the equipment, it is generally owned by a network service provider, and they, through this network service provider, they sell services to other users. So lastly, we're going to talk about the network called PAN. Now, PAN stands for Personal Area Network, and this network consists of devices such as your mice, your keyboards, your printers, your smartphones, and tablets, laptops, and other devices that deal with the individual person. And generally, all of these devices are dedicated to that one individual, and it is through a technology what we call Bluetooth. So let's talk a little bit about Bluetooth and what it does. Bluetooth is a wireless technology that allows devices to communicate with each other over a short distance. Now, this particular technology is a specification of IEEE 802, and the devices are capable of handling voice and data. Okay, so let's talk about rooting and jailbreaking and the difference between the two. Now, rooting and jailbreaking. Uh, what you have before you here is a mobile device, and this mobile device contains a bootloader. And so, just like PCs and laptops, the bootloader runs before the OS, just like Post runs before the OS. And the bootloader gives instructions for the hardware to start the OS application for these mobile devices. So the bootloader is locked for several reasons because it prevents modification to the mobile device and keep it out of harm's way of any attacks and viruses. So some of the things that the bootloader prevents is access or altering the system software that may cause damage to the device. It also helps the modification of the OS from being tampered with, and also access to the root directory. So rooting is done for Androids, and jailbreaking is done for iOS. And so either way it goes, whether if you do have an Android or a iOS or Apple phone, anytime you jailbreak or root these particular devices, you void the warranty on them. And if any, for any given reason that these devices are not operating properly, you cannot go in and have it serviced. Okay, so just some additional information about rooting and jailbreaking. Once that bootloader has been broken, the user can go in and tweak some changes to the OS, make some uh, overclocking of the CPU, and a whole lot of other changes can take place. So you want to again, please advise users or even yourself of the risk that's going to happen with the use of jailbreaking and rooting of a mobile device. So, let's talk about some networking equipment such as hubs, switches, and routers, as well as access points. Okay, so I am in a closet where there is some extra equipment, hub. We have some switches and some Cisco routers, and we're going to talk about what these network devices does as a whole. So I am going to talk about what a hub does first. So here I have a 16 port hub, and a hub pretty much extends the range of a network by receiving the data on one port and kind of regenerating the data and sending it out all of the other ports. So a hub can also function as a repeater, and a repeater extends the reach of the network and then rebuilds the signal. So, giving some basic information about a hub, one of the things that a hub does not do, it does not create a segment on the network, so that makes a decrease of the amount of bandwidth for all devices connected to it, as well as it does not filter data. So a lot of unnecessary network traffic constantly moves between the devices that is connected to it. So it's not very efficient with the traffic on a network. Okay, still talking about the different equipment that is on a network that allows traffic to flow across a network. And I'm going to talk about the difference between a bridge and a switch. Don't have an example of but to give a basic description of what a bridge does, a bridge filters the network traffic between the LAN segments. And so, what happens when the segments or the traffic goes across the network? The bridge keeps a record of all the devices in that segment, and then when the bridge receives a frame, it is examined for a destination address. Now, each one of these is a RJ45 port or a NIC, and on this NIC is a address that we call a physical address or the MAC address. And so the switch filters the MAC addresses to see which piece of equipment is plugged into these switch ports and where that information is to travel to. Now, a typical bridge has two ports linking two segments together on the same network. A switch, as you can see here, has multiple ports depending upon the number of segments that are linked together. And the switch is more sophisticated than the bridge. And so it gives more efficiency for the travel of data across the network. I'm just going to give a little bit more in-depth information about what switches do. Switches maintain what is called a switching table. And the switching table contains all of the MAC addresses on the network and the list of which the switch port can use to reach the device with that given MAC address. And so the switching table records all of the MAC addresses that come through the switch, and it inspects the source of which the MAC address of the incoming frame, as well as the port at which the frame came in on. Okay, again, this is the networking technology class that use Cisco products such as the routers and the switches. And the students use these routers in the class and they learn how to configure the routers as well as the switches. So we're looking at a industry router from Cisco. And so these routers or a router period connects network to each other, just like a switch uses MAC addresses to forward frames within a single network. Router uses IP address to forward packets to other networks. Now, on a corporate network, one router port connects to the WAN connection, and the other ports connect to the LAN. So, and also the router becomes a gateway and has a path that gives a path outside of the LAN to the internet or to the WAN. Continuing to talk about devices on the network. And what you see here is a wireless G 2.4 gigahertz broadband router made by Linksys. And it is also called a multiple purpose device. And so why it's called a multiple purpose device is that it performs more than one function. So it is more convenient for the user to go out and purchase this multiple purpose device than to go out and or all in one than to go out and buy several pieces to use on their network. So this is used in a home network or a small office home office network called Soho. So in the home network, this router is connected to the computers, whether they be wired or wireless, and it gets the user out on the internet. So here you can see on the back side of this multiple purpose device, there are switch ports here for the wired computers to be plugged into. And this port here is used for the RJ45 Ethernet cable to plug into and serves as a gateway for the user to get out to the internet. So this wireless router serves as a home gateway, a wireless access point, and a switch. Okay, we're going to talk a little bit about wireless securities. And the first one I'm going to talk about is WEP, which stands for Wired Equivalent Privacy. And WEP was the first generation security method that was used for wireless technology. So what does WEP do? It encrypts the broadcast data between the wireless access point and the client using a 64-bit or 124-bit encryption. Okay, so this wireless security WPA is a standard that is used by wireless technology that provides a better encryption and authentication than WEP. Okay, let's talk about WPA2 and what it does. And so WPA2 is a wireless technology that uses encryption with 128 block with AES to encrypt data. Now, it can be enabled in two ways. The first one would be personal, would use a password authentication, and enterprise, which would use server authentication. Okay, so the next wireless security I'm going to talk about is TKIP, or Temporal Key Integrity Protocol. And so what this is a patch for WEP that automatically negotiates a new key every few minutes, and it helps the keep the attacker from gaining enough data to break the encryption key. Okay, the next wireless security I'm going to talk about is AES, or Advanced Encryption Standard, which is a much more secure encryption than TKIP, which was added to WPA2 only. I'm going to talk a little bit about WPS, or Wi-Fi Protected Setup. So in the past, a lot of people, when they're purchasing wireless routers, would just go in and simply plug the device in and use the default settings, which left a lot of security holes, such as lack of encryption, the default SSID, and using the default administration password. So with Wi-Fi Protective Services was developed, it made it easier for people to set up their wireless networks a lot more quickly, easily, and a lot more secure. So that's just giving a brief description of what WPS does. Okay, this demonstration will be on the basic difference between wireless B, G, and N, and the different speeds and ranges that they have. So just starting out with some basic information on wireless technology for wireless routers. We know that IEEE created the standard for all wireless routers to follow, and that is the 802.11. So let's talk about wireless routers. Now, I have two Linksys routers. One is an N and one is a G, and these are the routers that our Cisco Academy students uses in the classroom. Don't have a B, but going to give a basic description of what B is and what B does. So 802.11b routers are no longer manufactured, but some of the newer routers still use the wireless B technology. Wireless B has a transfer rate of 11 megabytes per second, with the signal being good up to 150 feet, and the frequency range is 2.4 gigahertz. Now, there's a problem with this particular frequency range because it has the same type of frequency range as microwaves and cordless phones, which would create a interference with these particular appliances being around this wireless B router. So the user would want to make sure that the wireless router is not and in the area in which these appliances may be um, at, so there won't be any interference. Now let's talk about G. Wireless G 802.11 supports the transfer speed of 54 megabytes per second, and has a frequency range of 2.4 gigahertz as well. Um, that can still be cause a problem with cordless phones and microwaves, just like wireless B, because they are backwards compatible. So you still may want to keep your wireless network out of the way of these household appliances, so that your network won't have any interference going on with it. The difference between B and G is that G routers have a higher speed than B. Going on over to wireless N, we know that wireless N has a transfer speed of 300 megabytes per second with two antennas, and 450 megabytes per second with three antennas. Now, this particular Linksys router has three antennas on it, so this would get you the 450 megabytes per second with this particular router. So just keep in mind the difference between the different technologies of B, G, and N is the rate, transfer rate, the distance in which that these routers can reach, or and the speed in which they have. Still using the Linksys router as a visual, I'm going to talk about what a firewall is and what a firewall does. So we know that a firewall is a network security system that controls the incoming and outgoing traffic that is on your network. And so the firewall is pretty much a barrier between the internal network and a outside network, such as the internet. And so firewall comes in two different ways. You have a built-in one with Microsoft operating systems, and then you can go out and buy a firewall hardware and configure it to help ward off attackers and viruses. Okay, let's talk about the difference between port triggering and port forwarding. So the first one I'm going to talk about is port forwarding. And so what port forwarding does is it sets up a public service on your network, such as web server, FTP servers, and email servers. And the user sends these type of requests to your network via the internet. And so what the router does is it forwards these requests to the appropriate computer, and it's configured on your router if you're using a server for your computer, or if you're using a game server. So let's give out two types of port forwarding. You have single port forwarding, and with this type of port forwarding, you can set up public services one by one on your network, such as a web server or a FTP server or email server. Okay, again, with port forwarding, you have port range forwarding, and what this does, it allows you to set up public services in a group which is called range to port, and for example 20 to 25, and certain applications may require opening specific ports so they can function properly. So again, that is just a brief description of what port forwarding is. Port triggering sets up the router so that the computers can access the public services outside of the network or outside on the internet, such as web servers, FTP servers, and email servers, as well as game servers. Okay, let's talk a little bit about a DMZ, or demilitarized zone. And it is common for a firewall or a proxy to manage the traffic to and from a DMZ. And so a DMZ provides services to an untrusted network that gives protection to the internal network. So for like email and FTP server, they're often placed on a DMZ so that the traffic using the server does not come inside of the local network. I'm going to give a little bit of information on NAT, or network address translation. So what network address translation is a that it converts private addresses into the internet routable addresses. So with NAT, a private source IP address is translated into a public or a global address. And so this process is reversed for incoming packets. So the router is able to translate many internal IP addresses into public IP addresses by using NAT, or network translation, NAT address translation. Let's talk about PAT, or public address translation, which means is one address to many ports. So you may have 10 computers that use the same address but different ports. Okay, so this is a demonstration, and I'm talking about the what is A class, B class, and C class IP addressing. So A class generally associates itself with larger networks, and the range goes from 0 to 126 with the 16 million available IP addresses. Now 127 is used to loop back in the network. The default subnet mask that goes along with that is 255.0.0.0, and the 255 represents the network portion, and the zeros represent the host portion. Now, for the B class, IP addressing is used for medium networks with about 65,000 available IP addresses, and the range starts from 128 to 191, and the network portion of that IP address is, or that range is 255.255.0.0, with the zeros representing the host part. Now, the C class IP addresses is used for the smaller networks, and the range starts from 192 to 223 with 254 available IP addresses, and the network portion is 255.255.255.0. And so in here, with these IP addresses, they are represent the IP version 4 represents the 32-bit, which has 4 octets, and each octet is 8 bits. Okay, so let's talk about the difference between IP version 4 addresses and IP version 6 addresses. So as you can see, I've already wrote it on the board, and the IP version 4 has 32-bit, and this is a C-class IP address that I have wrote out, and starting with 192.168.1.0, and the 192 168.1 represents the network, and this represents the host. Over here, we have the IP version 6, which is 128-bit, and it's a three-part hierarchy. And so here, the first part of the IP address is, well, all of it is hexadecimal, but the first part here represents the global prefix. This part represents the subnet ID, and the last four blocks represents the interface ID. This here part, the global prefix, belongs to the organization through the Internet Naming Registry. So this is just to give a brief description of the difference between IP version 4 and IP version 6. Okay, talking about private IP addresses versus public IP addresses. So what I have done here is giving ranges for the A class, B class, and C class IP addresses. So here's the range for A is 10.0.0.0 through 10.255.255.255. B is 172.16.0.0 through 172.31.255.255, and a C is 192.168.0.0 through 192.168.255.255. Now the difference between private and public is that the private IP addresses cannot be routed across the internet, and public IP addresses can. Okay, talking about a PIPA versus static IP addressing. Now, a PIPA stands for Automatic Private IP Address, and what happens with the PIPA is when a Windows client is connected to a DHCP server, DHCP issues out a address that has been reserved in a pool. But sometimes the DHCP server goes down. So when that particular client is looking for an IP address and it cannot get one from the DHCP server, it goes and PIPA goes into action and issues the client address from this range of 169.254.0.0 through 169.254.255.255. Now, talking about static IP addresses. Static IP address are usually put on devices that don't move around in a company or on a network, such as servers. And so the administrator, systems administrator, would go into what we know as the TCP/IP dialog or the NIC, and go in and assign that particular printer a IP address. And so it comes up with a box or dialog box, and it asks for, you have your automatic choice, and then you have your choice for static. So you would go in and you would put a address in that static IP address box of 192, just an example, 168.1.1, and this address remains to be the same until that administrator goes in and change it. It would have also have a subnet mask that would go along with it, and if it needs a gateway, well, printers don't need to go out on the internet, so that gateway box would remain empty. Okay, here in this visual, I am going to demonstrate how to do a backup in Windows 7 versus XP. So backups can be done manually, or they can be scheduled automatically. In order to successfully back up and restore data in Windows, the appropriate user rights and permissions will be required to the user. So all users can back up their own files and folders. They also can back up their files and folders for which they have read permissions, as well as all users can restore their own files and folders for which they have written permissions as well. So let's begin showing how we do a backup in Windows 7 first. Okay, I also want to add that the administrator, backup operator, and server operators, especially joined to a domain, can back up and restore all files regardless of the assigned permissions. Okay, so in this demonstration for Windows 7 backup, we're going to click on the Start button, and then we want to click All Programs, and then we want to click on Maintenance and Backup and Restore. Now what you see here is a dialog box in which we took a path. And here in the control panel, if we had to use the control panel, you would have clicked on Control Panel, Systems and Security, Backup and Restore. Now in this particular dialog box, it says here Backup. Windows Backup has not been set up, so you have to go and set it up. So you would click on Set Up Backup. Now here you get a user account control dialog box, which is asking for a password from the administrator and a username and password from the administrator, and then you would click yes. So I'm going to go ahead and, because I have a junior admin password, username, I'm going to go ahead and type that in. And the password and click yes. Now here you see you have your setup backup dialog box that popped up, and now the dialog box comes up again, and then asks you select where you want to save your backup. And here it gives you a recommendation of where you should save your backup on the external drive, and then it gives you the guides to choosing a backup, and then here save your backup on drive D, which is recommended, and it gives you the free space and the total space that's available on that D drive, and then you'll go and save it. Since this drive is on the network, you would save it on the network and click next. What I did, I went ahead and click next, and this is the dialog box that popped up, and it gives you a couple of options, and it says let Windows choose what you want to back up, and which is a recommendation, or you can click and the option of letting yourself choose, and it gives you where you can choose library and folders, or to include the system's image in the backup. So you can, those couple of options you can do, rather letting Windows do it, or you can do it yourself, and then you would click next. And now you get a dialog box saying review your backup settings. So you got your backup location, which is on the D drive, And then here you have your items, all users, and your system image, which will be included in the backup. And here, right here, you see a schedule. So here it has been scheduled for every Sunday at 7 o'clock p.m. But you can go in and make that change under here. And here it says here a system repair disk might be required to restore the system's image. So once you have done all of this and you're happy with your settings, you can say go here and click Save Setting and run backup. So I'm going to go ahead and do that. And you get a dialog box that saves your backup. Here, another dialog box has popped up, and it's telling you here that backup is in progress. Here it's going on the D drive, and gives you more information. It's in progress. There's never been a backup, and the contents of the backup is in the files and personal folders for users and system image, and it has the schedule here as well. So I'm going to just go ahead and close that out. I need to also do a demonstration for backup for XP, in which I built a virtual machine on the Windows 7 machine host. So what I'm going to do is I'm going to go into the run box and type in the Windows virtual machine. And as you can see, a virtual PC. So I'm going to go ahead and click on Windows Virtual PC. And as you can see here, I have my XP operating system running under this virtual machine. So I'm just going to click it so that the XP can start. And so I'm going to start Windows normally. Now XP is starting. Just giving a while XP is starting up. Going to go ahead and give a brief description of what's going to happen here, just as we did in Windows 7. We're going to give a demonstration of how to do a backup for XP. So here right now we are at the virtual machine for XP welcoming screen, and now we're on at the desktop. So what I'm going to do for this particular, since it's XP, I am going to go ahead and start the XP backup and restore utility wizard. So what I'm going to do here is click on the start button. Click on all programs. And then I am going to click on accessories. And then I will click on system tools. And then another dialog box pops out, and I'm going to do backup. Kind of waiting for that to open up. Here at the bottom of the screen, because I just installed this virtual machine for XP, it gives you a little bubble or some directions of taking a tour for XP. If you remember back then when XP was first installed, you were able to take a tour just like any other operating system. Okay, so here we have the backup or restore wizard dialog box popping up. So I'm going to go ahead and click next. And here it says that dialog box again, backup and restore wizard. It gives you some options of what it is that you can do. What do you want to do? Backup files and settings, restore files and settings. So what we're doing at this particular time is we're doing a backup of files and settings. So we're going to go ahead and click next. And it gives you some more options here. What do you want to back up? So I am going to back up my documents and settings, or I can back up whoever is also a user on the particular machine. You can back up everyone's documents and settings, which includes every user's document folder, plus their favorites, their desktop, and their cookies. Or you give your option of all information on this computer, or just let me choose what I want to back up. So I'm just going to, for this particular demonstration, I'm just going to back up my documents and settings. So I'm going to click next. Now it's asking me for backup type, destination, and name. So here it says choose a place where you want to save your backup. So you have an option to do that, and you can do the drop down box. And its first choice is using a floppy, or let me choose a location that's not listed. So I can do that, or and my what I'm doing here is a backup. I can also go and browse where I want to put my which asks me to put a disk in the A drive or in the floppy drive. Okay, now here you get a save as, and I can either put it on the desktop, or I can put it on my computer or network places. And then the file is named backup, and you can save as type backup files. And I'm going to go ahead and save. Now, again, another dialog box comes up, and then it says choose a place to save your backup. So I'm going to, for this particular demonstration, it has it on the C drive, and saving it under documents and settings under my name, Anita, and to the desktop, or I can choose browse to point it into another direction or to another specific location, and I'm going to click next. Now here a dialog box comes up, and it states completing the backup and restore wizard. It gives me the name of documents and settings, Anita, desktop backup. It gives you the description when it was created and at the time, contents, my documents and settings, and the location is a file. Or I can go and it says close this wizard and start the backup. Click finish, or to give specific additional backup options, click advance. So we're just going to go ahead and finish this, and now the backup process begins. So I'm just going to cancel that out. And then the dialog box comes and say, are you sure you want to cancel this operation? And yes. And then it gives you that it was canceled. And then you can go ahead and close out that dialog box. Okay, so this particular demonstration will be on how to add an exception to Windows Firewall and Windows 7 versus XP. So the first thing that you want to do is, in order for some programs to communicate with the computer over the internet or the network, the firewall, what it does is it helps the computer by blocking certain types of communications unless you allow it. So the first thing that we want to do to allow program to communicate with the computer, you want to go to the start button. During the search box, you want to type firewall, and then click allow a program through Windows Firewall. This is in Windows 7. And then you get this dialog box. It could have been done another way. If I didn't do it through the search, I could have went through the control panel, did system and security, Windows Firewall, and allow program. So there are several ways in which you can this can be done. So here you have a warning. For your security, some settings are managed by your system's administrator. So this may mean when I start to try to make changes, I'm going to get a dialog box that's going to prompt me for a username and password. So I am going to go here and click change settings. So as I said, there is a dialog box that's prompting a username and password. So because I have a password, I'm going to type it in. And the password. And I'm going to click yes. So here the dialog box is up. Now I can make changes. So what I want to do, you can scroll down to pick the programs that you want the computer to communicate with through the firewall. So I am just going to pick remote service management, and here it clicks it in the domain. I can use which is the network. I can use it for home or work, the private, public, and group policies. So I'm going to go ahead and click OK, and those changes have been made. You could have also went through allow a program or feature through the Windows Firewall, and you get the same thing. Okay, here we have another demonstration on how to make exceptions for the Windows Firewall, but this particular operating system is XP. So what we're going to do is we're going to go ahead and click on the Start button, click on All Programs, and then I'm going to highlight Accessories, and then go over and highlight Remote Desktop Connection, and then right click and click Properties. And so we have the Remote Desktop Connection Property dialog box open, and so we're going to right click the target box and click Copy, and then we're going to cancel that. And that closes the dialog box. And then we're going to click Start again and Control Panel, and go over to the Security Center and open it up, and scroll down and click on Firewall. Now we have the Firewall dialog box up, and so I'm going to click on the Exception tab, and then click Add Program. And then once I have the Add Program dialog box up, I am going to then click Browse. And now with the Browse box open, I am going to right click the file name, and click Paste. Then click Open, and then click OK, and then click OK again. Now what it says is, because I did a trial run, tells me that it's already in there, an exception list. So I'm going to go ahead and click it OK again. And then I'm just going to cancel all of these other boxes out and close out of the programs. So that's how you do an exception for XP. Okay, for this particular demonstration, I am going to show how you change the user account control settings in Windows 7. So I'm going to click on the Start button, going to Control Panel, um, clicking on System and Security, and then under the Action Center, there's an option where I can change the user account control setting. So I'm going to click on that, and what happens is I get a dialog box asking me for a username and password. So I'm going to go ahead and, for this demonstration, as the others, put in the username and password, and hit yes, click yes. And now I have the user account control settings dialog box that opens up. And so it's asking me choose when to be notified about changes to your computer. And the reason why this particular prompt or option was included into Windows 7 is because users can, sometimes change programs, and it causes harm to the system, and that makes it much more difficult for the computer to operate properly. So this is a good option here to prevent issues down in the future. So here we have some options, and this one is the default, where it says always notify me when programs try to install software or make changes to my computer, or I make changes to Windows setting. Then when we're trying to install programs, or the user is actually trying to make changes to the Windows setting, you get that user account dialog box warning you that there is a change that's about to be made to the system, and do you really want to do that? Here down at the next level, you get some more options. Always notify me, and do not dim my desktop when programs try to install software or make changes to my computer, or the user, such as myself, is trying to make changes to the Windows settings. Here you can go down. It says again, notify me only when programs try to make changes to my computer, and don't dim my desktop, and don't notify me when I make changes to the Windows setting. And the last one here, never notify me when programs are trying to install or make changes to my computer, or even if the user is trying to make changes to Windows settings. Now, these last two are not recommended, so you want to always keep your system on the one for default, so that you'll be notified when a program is being installed or changes is being made to your system. So I'm just going to go ahead and cancel that out and close this. Now I'm going to go ahead and continue with this one with Windows XP. And for this demonstration with XP, I'm going to go ahead and still do the control panel, and I'm going to scroll down to the user account. And as you can see, under the user account, I'm going to click user account, but there's no option here for me to make changes to the user account control setting, because this option was not implemented until Vista. So XP does not have this option.